All right, this is the first video that I'm recording, and I will talk about all the patterns and all the things important in programming. So the first pattern that I chose in this first video. So we will talking about the factor pattern, and sometimes when I got this question, try to explaining about factor, and I always got confused because looks too much when we're trying to explain like the code, but it is not. So when somebody asks you about this factory pattern, just say, we use this pattern to delegate the creation about some objects. And I have two samples here. I have logistics sample, and after that we were talking about something more realistic because we use this a lot in test in the test in unit tests or in the test environment. So let's talk just a little bit. First of all, the objective about the factoring pattern. So delegate the responsibility of creating objects to another class or method instead of directly instantiating and using a new in the client code. Look at this. I don't care in how I will deliver the some some shopping or something like this. I just want that delivered. So logistic delivery from me. So first of all, I'm creating here a logistic road and or C logistics or air logistics, and I don't care. I just want this delivered. Looks simple, right? So the definition define an interface for creating an object, but let subclasses decide which class to instantiate. The factory method allows instantiation to be deferred to subclasses. Its intent is to delegate object creation to promote flexibility and extensibility in the code. All right. Factory method intent and applicability. The factor method patterns is about defining an interface for creating an object, but letting subclass decide which concrete class to instantiate. This defers instantiation to subclasses and promote loose coupling and extensibility. When to use the factor method, when you don't know in advance what type of object your code will need to enable extensions of object creation logic without modifying existing code. Open-close principle to decouple object creation from the code that use those objects. Single responsibility, single responsibility principle to give subclasses a hook to control how objects are created and to avoid duplication in object construction logic across the system. So this sample here that I have in my screen is not something like useful, but it's good to explain. Look at this. In air logistics, I'm creating plan. In road logistics, I'm creating a new truck. In sea logistics, I'm creating a new chip. That's it. So I don't want to know uh, which transport will create for me. I just want this delivered. And that's it. If I run this right now, let me run. So first of all, here we are delivering by land in a truck. The second planned delivery is by sea in a ship. And the third one by air in a plane. That's it. Looks simple. So common use case, creating different transport in logistics system. Building in a UI components dynamically based on platform or Windows button or whatever, providing different database connections depending on the configuration, return marks, returning mocks or stub in unit testing, constructing strategies or handlers dynamically in processing pipeline. This is most like the important things, but does it look simple in this situation? But let me explain this better. Uh, Before we dive in, we are already diving the code. So uh, remember, design patterns are language agnostic. So in this series, I will use .NET for demonstration, but these patterns applies to any object-oriented language. So again, just to fix it in our mind, what is the factor pattern? The factor method pattern allows you to create objects without specifying the exact class of the object that you create. This is useful when you want to delegate responsibility of instantiating objects or subclass or external components, reducing coupling. In this case, I could use something different and create another class and adding a parameter. So I will deliver this by truck or by ship or by plane, whatever. But this is the factory. I'm creating some logistics. I don't care if this road could be a truck or a car or a bicycle. Doesn't matter to me. And this logistics could be something, could have something else like it's close for the store, so it could run by a motorcycle. It could be delivered by a motorcycle or a bicycle. You know, uh, it's far away, so we need to use a truck. Or uh, it's in the same city, could be it could use a car. You know, so an analogy here. Imagine a coffee shop. You place an order for a drink, say latte, uh, and the barista knows how to prepare it. You don't care how it's made. You just want the result. That's it. That's exactly what the factory pattern does. You ask for an object, and the factory knows how to build it for you. Looks simple. I'm talking a lot here, but keep that in mind. Factory just create an object for me. And in this sample here that I have for you, looks simple, but we can let's think about some. I will show you that, but let's think about some tests. Sometimes I just want to build some service, and you can see the repetition of code because I need to use this service like in every test. So in this case, I can build a factory for this, and I will only use this factory to build this kind of service and use them in all my tests. All right, have this analogy and when to use. Commonly used in unit testing, dependency injection containers, object creation logics that change based on configuration, environment, or runtime conditions, avoiding large blocks of if else or switch to decide which class to initiate. So in this case, I have an iTransport. All right, let's close the others. I have this iTransport which only deliver. That's it. It's a common interface. Think of this as the drink as you order. Truck, ship, and plane are. Let me open them. Transport. So truck, ship, and plane. are specific implementation like the latte or an espresso. Logistics is the abstract factory. It defines the create transport. Here, contract. Road, sea, and air logistics decide which transport to create. They are the barista. Plan delivery shows how the client doesn't care what's created, just that it implement the expected behavior. This plan delivery. This is delivery. Logistic, plan delivery, create transport, and deliver. That's it. The factory pattern gives you flexibility and clean separation of concerns. When dealing with object creation, it's one of the most used patterns in the modern development, especially in writing scalable, testable code. Uh, After that, we can see the strategy pattern, which helps you replace large conditionals with clean and interchangeable algorithms. So, all right, this is just a simple sample, and let's see this right now. Uh, all right, let's continue. We I introduce you to the factory method pattern using a theoretical logistics sample. Now, let's look at a real world scenario that you will actually encounter in your day work unit testing. So, let's see the problem. When writing unit tests, you often need to create services with complex dependencies, mock, and even fake data. Repeating this setup in every test leads you to duplication, harder maintenance, and less readable code. Take a look at this. And what is the solution? We will use the factory pattern to encapsulate this setup logic into a reusable factory method. This keeps our test code clean and focused on behavior, not in a construction. Take a look at this. Uh, I could do something like this in my test. Instead, do this. So every time then I need a repository and a order service, I could use this always. And take a look if I need to change something here, and I'm using this all the time, and I need to duplicate this code like every time. So let's go back here. That's it. Now it's good. So the solution, we will encapsulate all the logical here. So I have the domain context, have an order. All right. It's just an entity. And I have a service, an order service, which use a repository to get by ID, get an order by ID. And I'm using an iOrder repository here, which use the get by ID is a contract, right? So that's simple. Now, notice how the test is clean and easy to read. Always remember that you are always building a code to a person, not for the machine. So person needs to get here and say and see something like this. So order service, get order. So I'm testing the get order. When I have a valid ID, should return an order. So I need to create this service, which is working like this thing here. So when I came here, create order, I'm creating a repository using a substitute, and I'm taking some information here. After that, I'm generating the fake order, and when the repository gets order, get by ID with any ID, return this fake order. So doesn't matter which code I used before, always is getting this fake order, and I'm returning the service. This is a fabric. So let's recap. The factory pattern here is not about complex object hierarchies. It's about encapsulating creation logic so your test code stays minimal, focused, and consistent. This improves test readability, reduces duplication, and isolates setup logic in one place, making your code base easier to evolve. Always remember, patterns are tools, not rules. Use them when they bring clarity and reduce friction in real world code. Uh, if you take a look at here, create order, because now I have some kind of factory uh, which build a lot of kind of the same service, because I'm testing uh, a lot of kind of services. So here I'm testing when I have a valid ID, I have with a valid order, I testing with no order exists, when a repository throws an error, and when I have invalid data. And I have this service factory here building all of them. So if I came here, view, test explorer, I can see everything and I can run right now. I will run everything. So that's it. We can compare this with the builder pattern, but is not quite equal, because in the factory pattern, always return a pre-configured object. In a builder pattern, you can configure this object step by step. In a factory pattern, it's good for fixed test scenarios. In a builder pattern, it's good for custom object construction. Actually, a builder pattern looks like this. But instead generation at the end we use build. But we'll get there. It's called chainable interface. So, but we will get there. So I think for today that's it. If you can get any comments or some feedbacks, I will appreciate that. And see you next time.